All right, so 9-4 arcs and chords we're talking about. So, first thing I just want to mention, you have a chord. Anytime you draw a chord, you're creating two arcs, okay? If that chord is not a diameter, you've created a major arc and a minor arc. Right? Do you follow me? So if I have a circle and I draw a chord, that's not a diameter. So remember, chords are segments whose endpoints are on the edge of the circle. Didn't I create a minor and a major arc? Right? So every time you do that, if it's not a diameter, okay? So here's some terminology I just need you to be familiar with. So let's just throw some letters in there. We refer to the minor arc as the arc of the chord, which is a little weird, but once you see it a bunch, you'll get the hang of it. So if I want to talk about, like, these things are related, the arc AB and its chord AB. So I would, gosh. I'm trying to think of a good way to phrase this. Well, let me just put it all in words. So a chord that's not a diameter creates a major and a minor arc. We refer to the minor arc as the arc of the chord. Okay, so this next theorem, if you look down at the next line, this is important to remember. So you might want to put a big star somewhere. I don't know, but this is an important topic. If you have a circle or congruent circles, all of these things are going to be true. So check it out. Congruent central angles. So if I have two congruent central angles, then I'm going to have congruent arcs, and I'm also going to have congruent chords. Okay, so let's just look at this in one circle. Let's try here. So if I have any one of these three, I get the other two, is basically what it's saying. See how the arrows are double-headed? So let's just say I know I have two congruent arcs. Let's start with that. So let's just use this circle here. So say I have arc AB, and then over here I have CD. And I know that that arc is the same length as this arc. Let's say I'm given that information, okay? So because I have congruent arcs, if I were to draw their chords, so chord AB and chord CD, they're automatically congruent to each other. And if I were to draw in their central angles, so to draw in the central angles, you'd have the center of the circle, and then you would just draw a radius to each point. So there's the central angle for arc AB, and then here's the central angle for arc CD. I would know that those two angles are congruent. That's what this is saying. So if I get any one of these three pieces, if I have two congruent central angles, then the arcs are congruent and so are their chords. If I had two central angles congruent, I think that's the one I just did. Any one of these, you get the other two. And it doesn't even have to be in the same circle. If I have two circles that I know are congruent, so I'll draw that with two separate circles. Is everybody okay with this so far? Yeah? Okay. So if I had two separate circles, I'll zoom in big. But I knew that these circles were congruent because they both have a radius of, who cares what? I don't know, X. So I know I have congruent circles because I have congruent radii. So if I have any one of these things, so this time let's do, say I had congruent chords to start out with. So say I had a chord AB and I had a chord CD. If I knew that AB and CD were congruent to each other, those segments, I automatically get arc AB is congruent to arc CD, and their central angles would also be congruent. So that angle and that angle would be the same. Does that make sense? So that gives you a whole bunch of information. So if you start off with a pair, one of these three things, you get the other two. We're okay so far? All right. We're almost done. Next one. If a diameter is perpendicular to a chord, then the diameter, and by the way, it doesn't have to be a diameter. It could be a radius too. A diameter or radius. So if a diameter is perpendicular to a chord, let's look at this. Oh, they gave me a circle, so I'll use it. What do we suppose is true? Let's have a diameter. So make your center dot. Draw a line through the center. I have a diameter, and they're telling me it's perpendicular to a chord. So let me draw a chord so that it's perpendicular to that diameter. Okay. Let's label some pieces here.
Isn't that also a diameter?
BD?
Oh, I didn't. I'm having a rough day.
Does AC bisect BD?
It does. Yes, you're spot on. So he just said, does AC bisect BD? He's absolutely right. And here's an easy way to see why. If I remember, what do I know? Let's call this point E. What do I know about EB and ED?
They're the same.
They're the same because they're both
Congruent.
they're both a radius of the same circle, right? So they're equal to each other. So don't I now have an isosceles triangle with basically an altitude drawn?
Yep.
And then we know from our isosceles triangle business that if I have an altitude, yes, it bisects that. Not only does it bisect that, but I also have bisected this top angle. Because remember, that altitude is really now a perpendicular bisector, a median, angle bisector. It's all those things. So that's a quick way to see why. So if I have and that's why it doesn't have to be a whole diameter, right? Because if you get rid of AE, nothing changes. So a diameter or a radius that's perpendicular to a chord bisects that chord. So let's fill that in. If a diameter or radius is perpendicular to a chord, then the diameter or radius bisects that chord. And then one last one. All we have to do is fill in two more blanks. In a circle or congruent circle. In a circle or congruent circle, if two chords are equidistant from the center, then thanks. There's one of these on your desk, and I'm recording all this, so hopefully you can watch it later if you want.
Thank you.
You're welcome. If two chords are equidistant from the center. So, imagine, let's draw it. Here's the center. Let's say I have two chords that are both the same distance from the center. So let's say I have that chord and I have this chord. How would I show that they're the same distance from the center? How do I show the distance from a point to a line? Do you remember? What's the distance from a point to a line? What do you do to measure that distance? we always refer to the distance between a point and a line as the perpendicular. So you drop a perpendicular. So what this is saying is, here's the scenario that I know. These two chords are equidistant from the center. You see that? So they're perpendiculars from the point to the line. That's equal. So now I have two chords that are equidistant from the center of the circle. What does that must mean about the two chords themselves? Yes. Then the chords are congruent. And how do I know that? Well, you could do some more isosceles triangle business again, okay? So if you don't want to muddy up your diagram, maybe you don't draw this in. But remember, I can draw in a radius to all these points. All the radii are the same length, right? So I know this is the same as this, and this, and this. So don't I really have, and they're all right triangles. So don't I have 4 triangles congruent by what? Hypotenuse leg? Right? So that's how I can now get, all right, those pieces are going to be the same. Does that make sense? So I'm not just throwing made up stuff. That really is true. So two chords, if they're equidistant from the center of the circle, they have to be congruent to each other. And you can say it the other way around. If the two chords are congruent, then they must
Be the same distance from the center.
correct.